In this video, I'd like to talk about the differences and similarities between the terms accuracy and precision. And while they sound kind of similar and people use them a lot back and forth, they mean different things. Accuracy pretty much means, are you getting the correct answer every time? And it could be that your individual measurements are all over the place, but if you look at the average of them, it is pretty much where it's supposed to be. If you get on a scale and you really weigh 200 pounds, if you look at the reading, it says 200 pounds. If you do multiple readings, they average out to around 200 pounds. Precision means you get the same reading over and over again. It may not be accurate, it may not be the correct answer, but it is the same reading over and over again. So giving the example I gave a second ago, if you weigh 200 pounds and you get on the scale and it says you weigh 220 every time, it keeps giving you 220, that would be a precise measurement. It's not accurate, but it is precise. And of course, what we're looking for is both. We want our measurements to be precise. We want an instrument, primarily, like a balance or something like that, to give us the same number over and over again. And of course, we want it to be accurate. And I just want to give you a couple different analogies. One of them is like a dartboard sort of a thing, a target. And if I were to throw some darts at this, and let's say one hit here, actually let me use a brighter color so it'll stand out. So one hits there, one hits there, one hits there, and one hits there. If you notice, my darts as I threw them were all around the target area, so you would say that it was not precise. So we'll do a little thing here. My precision is not so much, but if you average them, the middle, pretty much it's coming out right to the middle. So you would actually say that this is accurate. So the way I threw those darts there would be accurate but not precise. Let's say I started throwing them at a second dartboard and I got a pattern that looked like this. Okay, in this case you would say, well, that is very precise because I kept hitting the same spot over and over and over again. It's not accurate. I'm not hitting that bullseye, but I am precise. So you would say in this case the individual throwing the darts is precise but not very accurate. Another option is you have someone that's throwing them and they're kind of like this. So these darts, if you look at them, are kind of all over the place, so we'd say they're not very precise. And if you average it, it's going to average somewhere in the middle of all of them, so you would say it's not very accurate either. So these darts are neither accurate nor precise. And of course, what we're working for is something like this. We want something that is both accurate and precise. We get the same readings over and over again. Okay, how would this play out in actual readings? This is just kind of an analogy here. And so what I did is I have some student data here for you. And here's student A. And student A got these 4 measurements. So they were measuring something over and over again, and they got these numbers. The accepted value, we find out that the thing actually weighs 1.52 grams, 1.52, and they got these readings. Well, if you were to average all these together, this averages out to 1.725 or roughly 1.73. So if we look at these readings, we would say that this student is precise. They are precise because these readings are very, very close to one another, but are they accurate? No. The student is not really where they need to be, which is the 1.52. If we look at this second student, student B, look at these numbers, 1.32, 1.72, 1.22, and 1.83. Well, right off the bat, without even looking at the average, I'm going to say that this kid is not precise. Student B is all over the place with these readings, so they are definitely not very precise. Now, are they accurate or not? Well, let's look at the average. To get the average, if you add up these 4 numbers and divide by 4, you get 1.5225, which actually rounds out to 1.52. Well, my accepted value is 1.52, so this student is actually accurate. Numbers are all over the place, so not precise, but definitely they are accurate. Student C, if you look, these numbers are all very, very similar. They actually average out, of course, as you can kind of see, they're going to average out to 1.52. So these numbers are both very close to one another and close to the accepted value. So we would say student C is both precise and accurate. And for student D, again, looking at these numbers, they are up and down. They're all over the place. 1.32, 1.95, 2.8, 2.10, nowhere near one another. And if you actually look at the average of all these, it comes out to 2.0425, which would round out to 2.04. So if you look at the average, of course, this student is not accurate. And if you look at the precision, of course, they're all over the place as well. So this student would be neither precise nor accurate. So I hope that gives you just a bit of a feel for the difference between accuracy and precision. And again, accuracy means you're getting the correct answer, or at least the average of your readings comes out to be the correct answer. Precision means you're getting the same readings over and over again. May or may not be correct, but it will be the same readings. All right, thank you very much.